The water cooling manifold, shown here and furnished by Centrifugal Casting Machine Company, attaches to the customer's 3 supply pipes with 3 separate sections to cool the mold selectively and maintain the mold temperature evenly along its entire length. The separate sections may be turned off and on individually for selective cooling. The mold is being heated to a temperature of about 300 degrees Fahrenheit for applying the SPP wash. Here is the variable speed 75 horsepower eddy current drive motor connected to the centrifugal casting machine, which allows infinitely variable speed control in startup and also running and also braking forces. Here's a view of the Rolance spray coating system, including the lance and its support system and drive system. It is shifted to one side on the back side of this retaining wall or this safety wall when it's not being used for coating the mold. This lance has a special CB 360 degree spray nozzle, which allows for uniform coating of the mold's surface in multiple passes. Here is a view of the centrifugal casting machine installation from behind the operator's console. The console has controls for starting and stopping and varying the speed of rotation, as well as the timers for controlling the water on and off cycles. Also controls for the casting rotating equipment, which is used after the casting is extracted. In this view, from the extraction end of the facility, we can see the mold being preheated, and to the right we see 3 independent casting support assemblies, which can be adjusted in height uniformly to match that of the inside diameter of the mold. Each of these casting supports has a roller assembly and an elevating screw to facilitate proper adjustment and also smooth extraction of the casting from the mold. As we can see in this picture, this casting machine has been integrated into a conventional dry sand mold foundry. This shows the Rolance spray lance equipment with the spray tank in the background near the operator's control console. And here we have a technician who is adjusting the balme and viscosity of the wash so that it is proper for the application on the inside of the mold. The spray tank is equipped with separate air regulators for liquid supply and air supply for the CB nozzle, as well as on-off control of the spray liquid to the lance. Here you can see commissioning personnel adjusting the height of the lance using a hydraulic jack to be sure it is at the proper level. A supply of fresh water for washing the equipment and maintaining cleanliness around the machine is important. The Rolance is now shifted into position in direct alignment with the center of the mold, and the mold is increased to the casting speed in RPM in preparation for coating. The CB nozzle has been pre-purged and inspected and ready for coating the mold. The operator then initiates the cycle, and the lance moves forward into the center of the mold. There is a time delay before the spray nozzle comes on to allow the spray pattern to fully develop before it enters the mold. The lance proceeds through the mold until it reaches the pouring end of the casting machine. Three passes with 2 coatings each are used to develop a 1/32 inch coating in this mold. While the lance is being used to coat the mold, the runner pot or funnel for pouring into the mold is being preheated by gas torch. It's preheated to a temperature of about 1600 degrees. At the same time, this pouring pot is being heated. Also, the transfer ladle is being heated to appropriate temperatures to avoid temperature loss. The pouring car is advanced almost into position, and then the runner pot is lifted by crane and placed on the pouring car with the spout so positioned to properly center on the mold. Wooden wedges are used to secure the runner pot in position after it is properly located on the casting machine environment between the concrete walls. The spout is properly aligned with the mold so that the pouring car can be advanced all the way until the runner pot spout is fully inserted into the mold. In this case, the runner car is advanced until it touches the mold cooling manifold. This determines the proper location for the pouring spout. Here we can see the inside of the runner pot, heated and ready for use. Here is a top view looking down to show the spout. The metal is now heated and ready for pouring into the transfer ladle. A sample is taken for analysis, and then the metal is weighed on a scale. Proper metal weight is very important because all of the metal will go into the mold and determine the actual thickness of the casting. Once the metal has been weighed, if there's any excess weight in the ladle, it will be poured out. This will assure that The casting, when poured with 100% yield, will be of the proper thickness. Now that the metal is weighed, it is ready for pouring. Pouring time is very critical. Must be poured in a very short time in order to properly fill the mold. The mold is poured quickly, and the metal advances from the pouring end to the extraction end and is held in place by the end rings in both ends of the mold. The water is turned on within about 15 seconds after pouring when the metal is properly in place in the mold. The cooling water cycle is different for different castings and is important to the proper quality of the casting when extracted. The water is turned off at the proper time, allowing the mold to heat up so that it will expand and facilitate the extraction of the casting as it contracts. Here we can see the solidification still taking place inside the rotating mold. How the mold is stopped at the proper time after solidification is complete. The keys are removed from the end of the mold, allowing the end ring to be removed so that the casting can be extracted. The extraction tool is put into place by the operators. It is connected to a cable and then to a winch to facilitate the pulling of the mold by the winch. As the casting is extracted by the winch, it is controlled by the operator using a hand push button. The person who is extracting has complete control of the extraction process, and the casting is extracted onto the casting supports. It is then lifted from the casting supports and taken either to the casting cooling area or other appropriate place. Here we can see the second casting being poured. The mold has been recoated quickly with 3 coats of wash, and another ladle of properly weighed metal is brought into position and poured into the spinning mold. The solidification begins on the outside diameter of the casting and solidifies progressively through to the center of the casting. The inside diameter of the casting solidifies last, providing directional solidification and elimination of any shrinkage defects in the casting. The proper timing and amount of water cooling can be developed for providing optimum quality and solidification time in each particular casting. now complete with water, and the casting is rotated for an additional period of time to assure proper solidification. Again, the end rings are removed by removing the keys or retaining pins to allow the end ring to slip out of the end of the mold. Here we can see the pulling or extraction process taking place from behind the specially designed extraction winch. This winch is very specially designed to provide the proper speed and power and control by the operator for this process. Casting is then extracted to the casting supports and then lifted by an overhead crane and taken to the specially designed casting rotating assembly provided by Centrifugal Casting Machine Company. This casting rotating unit is provided to rotate tubes during their initial period after extraction to avoid warping of the casting and avoid ovality or squatting of the casting while it is still at a critical temperature. This assures a uniform, smooth, shaped casting. The extraction of the casting at a high temperature for various reasons without causing damage to casting while it is cooling. Here we can see the Model K centrifugal casting machine after the pillow blocks have been adjusted to the second position in length and the second position in diameter. They've been pre-pinned at the factory, so they're quickly movable to their second locations and pinning in place with a minimum amount of alignment required. The mold is a shorter mold, approximately 7 feet in length. It's being coated again with the same lance, 3 passes, but the end rings are left off in this case because of the smaller diameter. To maintain the mold temperature while the mold is being coated and the metal prepared. A smaller ladle is used now because we're weighing a smaller amount, and the scales is placed in front of the furnace for more careful weighing of smaller amounts of metal. Since all the metal is poured into the mold and there's 100% yield, the final thickness of the casting is determined by the weight of the metal poured. The ladle is moved into position for pouring and poured very quickly, about 7 seconds. The water is applied to the mold after about 16 seconds delay to assure that the metal is in place uniformly in the mold. Again, the water cycle is determined by the casting requirements for proper solidification. If desired, some of the water cooling manifolds may be turned on or off for selective cooling. This is determined after measuring the mold temperature, after extraction, and before pouring. The end rings are removed in similar manner after removing the retaining pins, and on a small casting and a small mold, the puller is used manually by 1 or 2 people because of less pulling forces required and the ease of removal when using the special SVP wash. Assistance is provided by 2 other employees to support the casting at both ends as it is extracted. It is placed on the casting supports and then lifted by the overhead crane, which conveys the casting away to the casting cooling rotator.